This presentation was originally delivered at the 2015 HERDSA Conference in Melbourne. This project was a collaboration set up at UNSW to develop and trial a new tool for running histopathology classes, where we aimed to provide an interactive and collaborative experience utilizing a digital image bank in face-to-face classes. Histopathology is the study of the microscopic structure of diseased tissues, and it's used in a clinical setting to diagnose disease and help identify the best treatment. This image here is an example of a digitized glass slide. Histopathology typically relies on the use of microscopes clinically, with the creation of glass slides with sections of tissue that are stained and examined under the microscope. A team at UNSW, led by Professor Rakesh Kumar, set up Australia's first virtual slide repository in 2003. And this changed the way it was taught, with less focus on the technique of microscopy and more on the tissue itself. Digital pathology has also changed histopathology at the clinical level, with the possibility of rapidly sharing images globally for diagnosis. The problem with teaching and studying histopathology is that it can be difficult to ensure that everyone is following and understands. The image here shows a multi-header microscope session, led by a pathologist, who controls the microscope while the students all look down eyepieces at the same feature. The histopathologist points out features using an arrowhead under the microscope and asks questions for the students to ensure that they understand. The downside to using a multi-header microscope is that it's only available for relatively small numbers of students. The goal, therefore, was to develop a scalable tool that provided students with the experience of collaborating using a multi-header microscope, while at the same time giving academics feedback about student understanding. In order to do this, in 2012, academics from 4 Australian institutions came together to set up a teaching network, the Biomedical Education, Skills and Training Network, or the BEST network. The goal was to improve biomedical education, both in Australia and internationally, by supporting the collaborative sharing of educational knowledge and resources. The network now has over 1,600 academic members and over 3,900 student members. The project included the creation of a cloud-based image bank, where images from many institutions were easily searchable and accessible for biomedical teaching and research, limiting the costly duplication of resources that can occur across institutions. The goal was to also develop tools that allow institutions to run classes around these images. An example of this is our Slice annotation tool, that allows you to mark regions and features on images using pins, rectangles, circles, or polygons, and to add your own notes to these annotations, to build up knowledge on an annotation layer. These annotation layers can then be shared with students and staff. Following the development of this tool, we wanted to test the ability for it to provide a collaborative environment for academics and students. To do this, we used the UNSW Rational Use of Investigation course. It's a small group of students with only 16 in the class, and the course runs based on cases. Originally, a pathologist led students through a multi-header microscope session. Following the development of this tool, all slides were digitized, and a second pathologist was included in the course to allow students to be broken down into 2 different groups. One group who would go through the multi-header microscope session, and the second group who would be taken through a computer-based session on the same slides. In the slice-based exercises, students were asked to use the annotation tool to mark features and include notes. These annotations were then shared via a database to allow all students to access all of the annotations. The annotations were then brought up in class on the main computer, and the students were given feedback by the pathologist. Regarding the study design, as I mentioned, students were separated into 2 groups. A total of 24 slides were used over 4 sessions, with the same slides being used for both slice and multi-header sessions. Typically, students had access to the same slides in both the real and virtual sessions, and groups interchanged during each session. However, several slides were identified beforehand as assessment slides, and these were only viewed by students using one method. Any teaching points and time spent on the slide were agreed by pathologists beforehand. After the exercise, students were tested on histopathological features after learning with SLICE or the multi-header microscope. Results showed that students that participated in the SLICE session performed slightly better than those that had participated in the multi-header session, and this was the case for both the first and second assessment items. However, it's worth pointing out that these results were not significant, though we note there was a very small number of students who participated in this study. In addition to completing an assessment task which was designed to assess student knowledge, students also completed an evaluation survey. Overwhelmingly, the results showed that students were very favourable to the use of SLICE in their classes. They preferred using SLICE in class to discuss slides when compared with the multi-header microscope. They found that sharing annotations helped their understanding, and that they received better feedback on their understanding using SLICE. They also agreed with the statement that the SLICE annotation tool allowed them to collaborate with their classmates and their lecturer, which we saw as a great success, as our goal was to provide a collaborative experience similar to the multi-header microscope. Some of the quotes we received from our students were that it was very user-friendly, it was a great interactive piece of software, and it was good for interacting with histology images. Another student noted that it was a great way to explore and discuss different versions of answers provided by different students, and to have incorrect answers explained by their tutor. It was a positive result for us that students reported that SLICE gave them the opportunity to collaborate with both students and their teacher, that they found it easy to work with SLICE compared to the multi-header microscope, though this student cohort had been working with virtual slides since the start of their university degree, and as such were likely not as familiar with microscope technology. Students also related feedback via SLICE and the use of SLICE to better understanding. Looking back at our goals, we concluded that we had created a collaborative experience similar to working on a multi-header microscope. The great benefit of the use of SLICE in class is that academics can now see exactly what students are understanding and adapt their teaching style to remedy any misconceptions. As an online tool, SLICE is completely scalable, and with universities increasing class sizes, the movement to online resources increases resource efficiency. Thinking about the future of our SLICE image bank, we opened up access to other histology and histopathology classes at UNSW, but it's also available to other institutions around the world. After the success with this small group of students, we opened up access to all of the student members in the BEST network. And since this, we've seen a huge growth in the number of annotations that are made on SLICE images, with over 70,000 annotations. And this number continues to grow by the day. We're also extending the functionality, removing the need to collaborate within an LMS. This will allow students to receive feedback directly within SLICE, streamlining this process. The best part is that through our website, best.edu.au, you can get access to over 18,600 biomedical images across a wide variety of disciplines and contributed from institutions around the world. Join us today to check out our catalogue of tutorials and images.